Hello, this is Jack Jackson. We're going to continue looking at how we can apply the things that we've learned about transformations of graphs of relations, specifically functions, to trigonometric functions. In any good pre-calculus or trigonometry class, the techniques of the previous section, previous video, are applied to the graphs and formulas of the six basic trigonometric functions: sine, cosine, tangent, cosecant, secant, and cotangent. We can use my geometry activity that I introduced last time for transforming functions in general to examine these transformations by typing in the basic trigonometric function in the input box. However, I found it useful to have the following GeoGebra activity that is specifically designed for examining transformations in trig graphs. So in the context of this application, we are making the following changes to some of the letters that we used last time, and for the parameters. And these are the changes that we're making to the basic trig functions, the transformations in the following order. There are four transformations. The first one, we replace x by 2 pi over p times x for some constant p. In other words, we're replacing x by x divided by p over 2 pi. Well, this produces a horizontal strain about the y-axis by a factor of absolute value of p over 2 pi. So every point is absolute value of p over 2 pi uh, times as far from the y-axis. In other words, we're multiplying the x values by that, or at least the absolute value of it. Since the basic sine, cosine, cosecant, and secant functions have a period of 2 pi, then p is the period of their transform functions with this setup. Since the basic tangent and cotangent functions have a period of pi, the period of their transform functions are going to be half of the p value. In the app, p is illustrated by a purple horizontal line segment. If p is negative, then the graph is also reflected over the y-axis. Notice that we used an a last video where we're using a p over 2 pi in this section. I'll show you all this in the actual app in just a second. Second transformation, y is replaced by 1 over a times y, or y divided by a, for some constant a. This produces a vertical strain by the absolute value of a. If a is negative, then the graph has also been reflected over the x-axis. Okay, so the first one gave us a horizontal stretch, which changes the period. The second one gives us a vertical stretch. A is called the amplitude of the graph for sine, at least for the sine and cosine graphs. And the amplitude is half of the vertical distance from the minima to the maximum points for those sine and cosine. A is illustrated by orange line segment in the app. Notice that we have replaced the generic parameter B from last section with the capital A here. So the way this is set up, we do those stretches horizontally and vertically first, then we do the translation. If x is replaced by x minus phi for some constant phi or phi. Phi is the amount of horizontal translation. This is known as the phase shift. Phi is illustrated in the app by a light blue vector. Notice that we have replaced the generic parameter h from last section with phi. And then finally, we replace y by y minus c for some constant c. C is the amount of vertical translation. If we graph any of the graphs over one period, any of the basic trig graphs, and compute the average y value over that period, that y value is 0. So C is the average y value for the transformed function. Okay. So the line y equals c is sometimes known as the center line for the function. Y equals c is of course a horizontal line that's graphed by a black horizontal line in the app. Last video we called the CK for the amount of vertical shift. So if we start with, for example, y equals sine of x, and we make these transformations and solve for y, then the form of the equation looks like this: y equals c plus a sine of 2 pi over p x minus phi. So specifically, suppose with that c be 1, a is 2, so the center line is y equals 1, the amplitude is 2, the period here is 3 pi, and the phase shift is pi over 6. We can see that here. The phase shift here is pi over 6. So here's the basic sine graph here. One period of it is 2 pi from here to here. The new period is going to be 3 pi. That goes all the way from here to here. So if you look at where this one starts here in the thing, when we get to here, we're back to the same place. Or if you went from maximum to the next maximum, or minimum to the next minimum, that would be a distance of 3 pi. Amplitude then is the distance from the center line up to the maximum, or from the center line down to the minimum, or half the distance from the minimum to the maximum, the vertical distance there. And so you can see these things illustrated. Let's actually pull up the app. So here it is, what we just saw there. So if we kind of set this to, let me kind of show you how these things work one at a time. If we start with an amplitude of 1, a center line of 0, and a phase shift of 0, and a period of 2 pi, that is the original graph, right? It has an amplitude of 1, a period of 2 pi, no phase shift, no vertical shift. Center line is the x-axis. Okay, now if we take this and we do it one step at a time, then the first step we want to do is, let's say, is the period shift. So if instead of 2 pi here we have 3 pi, that's going to extend, that's going to stretch it horizontally. So that's the first. So now the equation of that would be, that one would be just be y equals sine of 2 pi over 3 pi x, or in other words, sine of 2/3 x. Okay, next we want to do the change the amplitude. So if we change the amplitude, say to 2, now we took that one and stretched it, not the original one, but the transformed one. Now this is going to have an equation of y equals 2 times sine of 2 pi over 3 pi x times x. Now the next thing we're going to do is we're going to do the phase shift, and I think the example I had was pi over 6, and so we're going to shift that over. So this point, which was an x-intercept right at the origin, has now been shifted over to pi over 6. See? In fact, everything's been shifted to the right by pi over 6. That's called a phase shift, usually. And the vertical shift then is we can change this. Let's say we move it up 1 here. So now you can see the amplitude is 2. Phase shift there is pi over 6. New center line is at 1. And the new period is 3 pi. Okay, so that's one example. We can do a similar thing with cosine. There's a cosine. If we make the same changes, we get the same sort of result there. Here you see this maximum moved over, and that goes up. Okay, and of course we can change the period. We make the period bigger, it gets longer. It's a horizontal expansion. That's a strain, horizontal strain, or we can let it get smaller and smaller with this period, smaller and smaller period. Now, if we replace it by -1, now it has a period of 1. Okay, but it's also been flipped upside down. So notice that instead of, let's go put the phase shift back at 0. So instead of starting at, um, well, this one's actually just going to flip it over the y-axis, which doesn't really change anything. Okay, so for cosine, that's not going to matter. For sine, you're going to see it flipped upside down. So instead of first going up to a maximum, this one's first going to go down to a minimum, right? Let's see what else. Here's tangent. Now tangent, the period, this is not actually the period now. The period is, let's go back to 2 pi here. So if you go through 0 to 2 pi, notice that this thing goes through 2 whole cycles instead of just 1 for the original one. Well, for both of them in this case. This one is just shifting the whole thing up and down. This one is dealing with the stretch or compression vertically. And if it goes into the negatives, now it's switched upside down. Okay. Cosecant. Same kind of thing. Secant as well. And so you can look at different combinations of these things as well. You can turn some of this stuff off if you don't want it there. So there's just a graph of sine and cosine. What's interesting is that sine and cosine are just shifts of each other. If you'll take the cosine graph and shift it by pi over 2, you'll get the sine graph. Watch this. So let's shift it by pi over 2, phase shift. Pi over 2 to the right, and look at the cosine graph. And let's put it back to amplitude of 1 and center line of 0. And notice that is the same as that sine graph. So sine and cosine are just shifts of each other. Same thing for secant and cosecant. See how that's the same? Not for tangent and cotangent though. So you notice tangent is always going up, cotangent is going down. There's lots of really cool things to investigate with these particular graphs. For this purpose right now, I'm just showing you how some of these transformations work. And so it gives you just another class of examples that are very standard, that are studied all the time in high school, college curriculum, where we're applying geometry transformations to algebra, pre-calculus, in this case trigonometry as well.